This is Yuan and Chad from Nvidia. Yuan is the senior director for software, and I'm one of the product managers for cloud gaming. So I'm here today to talk to you about Nvidia cloud gaming with ARM servers. So generally speaking, 2020's challenges in the cloud gaming market are the growth of ARM adoption in both the data center and edge. With COVID-19, society has leaned on cellular technologies more than ever. Streaming media for entertainment, the use of virtual classrooms for education, and video conferencing for social interactions. Today, I would like to focus on cloud gaming or cloud graphics. So NVIDIA has invested in cloud gaming for over 10 years. Through our journey, we've discovered multiple limitations, and to advance this industry, we've solved many problems in not just software, but hardware. In 2012, we announced our Kepler generation, where we physically changed our GPU and added components like encoders, and also transitioned from actively cooled to passively cooled heat sinks to better fit the servers. In 2015, we launched NVIDIA Grid, where we hosted a US-based beta for cloud gaming. This was exclusive to NVIDIA Shield devices. During this process, we built out multiple versions of our software stack to learn how to best scale cloud gaming workloads. In 2018, we created the RTX Blade server to scale lights-out data centers for cloud gaming. We simplified maintenance by creating a server based on hot swappable nodes. So instead of requiring the manual disconnection of cables, unbolting, or unracking of servers, the RTX Blade server's design was modular. Just slide out the red flashing blade, pop in the new one, and our software stack does the rest. Over the years, we've built one of the world's most revolutionary cloud gaming services, GeForce Now. Gamers can finally play games that they own for PC on various devices, like MacBooks, Chromebooks, Android phones, and energy-efficient notebooks. This all comes at no technical debt for game developers. If their content works on PC, it'll run on NVIDIA GeForce Now. So what does this all mean? So it means that we're taking this vast knowledge and industry-leading experience and are applying it to the Android and the cloud ARM ecosystem for companies involved in cloud gaming or cloud graphics. We're actively working with CSPs and middleware providers to deliver end-to-end, low-latency, high-performance gaming experiences from the edge directly to the hands of gamers, supporting a variety of consumer devices. To do this, we plan on supporting all major ARM server CPUs, including key focus on Ampere Altra and Inspur servers, and Marvell and Gigabyte servers. With our combined technologies, we can advance the market of Android-based cloud gaming by delivering more users per server than ever before. The key ingredient for cloud gaming is the NVIDIA GPU. This is the NVIDIA T4. At 70 watts, it's designed to be powered via PCIe. It doesn't require supplemental power from the power supply. It also contains a robust video encoder that when paired with our cloud gaming software stack is powerful enough to support 32 simultaneous mobile games at 720p 30. Also for this software stack to work, we need a firm foundation. This foundation consists of components that are capable of directly accelerating software functions in hardware. The end result is improved security, lower latency, increased power efficiency, and reduced stress on the ARM cores. The CX6 is a host-managed device and supports hardware offloading of streaming, networking, and storage. It leverages features like SRLV to reduce the CPU utilization of virtual switching, RDMA Rocky to optimize the storage traffic, built-in QoS to guarantee bandwidth per physical function, improving streaming quality, and features like ASAP2 match action classification to classify network flows at the packet level in real time. The BlueField 2 is similar to the CX6 in regards to supporting offloads, but it adds an additional layer of hardware security. Unlike the CX6, which is host managed, the BlueField 2 can manage itself completely out of band. You can think of BlueField 2 as a small ARM companion system that discreetly handles network and security services for your ARM servers. Similar to how we had to evolve the GPU early on for cloud gaming to succeed, we now need to guide ARM server designs. To do this, we would like to review a reference architecture for cloud gaming or cloud graphics workloads. Our target again is 32 concurrent users per GPU, streaming at 720p 30. To achieve the target, we recommend 2 to 3 ARM cores per game stream. These numbers are dependent on the processor architecture and are currently targeting both the Marvell TX3 and Ampere Altra designs. Ideally, the system also has multiple memory channels. We've seen scenarios in the past where under-provisioned memory channels can lead to issues such as micro-stuttering during gameplay. To increase storage IOPS, we recommend 1 to 2 NVMe drives per socket at Gen 4 speeds. For networking, we recommend an OCP 3.0 form factor. However, traditional PCIe by 16 slots will also work. Additionally, we recommend using the Mellanox Bluefield 2 or Mellanox C6 to support the hardware offloads mentioned earlier. The GPU, for the most part, has been the biggest challenge. Today most ODM options either A, do not have enough physical space for full-size GPU, or B, they do not have enough power for it. So we recommend 1 to 2 full-length single-wide GPUs per socket. Each GPU would also require an additional 8-pin PCIe power connector to support the power demand of 150 watts per GPU. So looking at the attached diagram, you can see that we also need a somewhat unique PCIe topology. So we would like to eliminate traffic between processors where possible. To do this, we recommend balancing the GPUs and NVMe adapters on each of the sockets. So this concludes the hardware portion of the talk. I'd like to now pass things over to Yuan, who's going to cover the software side of cloud gaming on ARM.
Thank you, Chad. On top of the powerful platform of GPU, DPU, and ARM CPU sits a mature software stack. Our core cloud gaming SDKs from GeForce Now have been ported to ARM to share the best quality, density, and feature sets with the ecosystem. This allows us to offer up to 32 instances of game rendering, encoding, and streaming of a single GPU. Our game-ready driver is the gold standard in gaming experience. For Android cloud gaming, we brought native GLES driver that will go directly to the metal for Android graphics workload, ensuring the best performance possible. We have an extensive video SDK that is widely used in the industry. By utilizing our dedicated hardware encoding unit on the GPU, it offers highly flexible and performant encoding processing. Coupled with the video SDK is our streamer. We are taking our Android streaming expertise from Shield TV, the best 4K Android streaming device, to the server side, combining with our GFN streaming stack. Together, the end-to-end streaming solution offers the optimum latency, picture quality, and network handling. Our Tesla and Mellanox enterprise software, including virtualization, are broadly adapted in data centers. By deploying these on the ARM platform, we bring great quality of service with fair scheduling, security, and session isolation. The offload of data processing in storage, streaming, and networking from the CPU to the DPU can further differentiate the quality of service achievable on the hardware platform. We offer our entire software stack, as well as the individual SDKs, to allow flexible ways to quickly integrate and deploy services. A key component of our offering is the VGPU virtualization solution, which has been successfully deployed in many of our enterprise customers. VGPU offers secure isolation and manageability over a large number of seats. It enables us to split the GPU resources efficiently, guaranteeing the experience of each user while maximizing the utilization of each server node, driving down the cost per user. Flexible VM profiles are provided to accommodate games of different levels of rendering and frame buffer requirements. Customers can easily scale up to more demanding content over time with different software profiles. The other key to cloud gaming is an efficient capture and stream software stack. We offer turnkey solutions that take care of capturing, encoding, and streaming in the most efficient manner, from server side to end device, adapting to the network condition along the way. With ideal game content, network condition, and input latency, we can go below 100 milliseconds for photon-to-photon round-trip latency. On the server side, our hardware and software SDKs can stream content of up to 120 Hz or up to 4K in resolution. Our parallel hardware pipeline for rendering and for encoding ensures maximum throughput with minimum CPU load. We support high-quality encoding formats with customizable parameters for the optimum balance of bandwidth and quality. While 5G network promises groundbreaking speed and latency, user can still experience network variability. Nvidia Streamer software intelligently optimizes for the best quality for the current network condition. Through features like dynamic flow control, adaptive dejitter, and many others, users will be getting the best possible experiences on their network. On the client side, we support all the most popular devices, including Android, Windows, and macOS native clients. For Chrome OS and iOS devices, we offer flexible WebRTC-based streaming. To tie it together, here is a block diagram of the Nvidia Android cloud gaming software on the platform. Starting from the bottom, we have the ARM server with Nvidia GPU and DPU. In the host OS, we run KVM hypervisor, GPU host driver, and VGPU management software. For the Mellanox DPU, we have the OpenFabric enterprise distribution for Linux. Sitting on top are the individual game streaming sessions, each packaged in a Linux VM, with up to 32 of them per each GPU installed in the server node. This ensures each game session is security isolated and easily deployed. Without disturbing its neighbors, we can manage each VM sessions and reset as necessary. Within each VM sits our guest driver and the cloud gaming SDKs, our capture and stream SDKs, and our acceleration SDKs like Optical Flow and Cloud XR, which provide innovative ways to accelerate motion vector processing and AR/VR streaming. In the middle sits our Android Cloud SDK that bridges the cloud gaming core stack with the Android system, encapsulated in an Android container. We provide Android Hell plugins to seamlessly integrate with the Android system for rendering, input, and video services. Our GLES driver sits inside the Android container. Once the game session is set up, Android game will be able to issue rendering commands to the GPU hardware interface directly through the GLES driver, without the overhead of translation or emulation. We're constantly expanding and improving our core cloud gaming stack through our operation of the GeForce Now service, as well as through requests and feedback from the ecosystem. Continuous software updates will add increasing value to the platform over time. We look forward to collaborate with partners to accelerate cloud gaming and the ARM ecosystem. With that, we conclude our talk today. We're eager to hear any questions and feedback. Thank you very much for tuning in, and enjoy the rest of the summit.